Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 12 noon on Saturday in Hong Kong. We're broadcasting live from Thousand Oaks, California. Thank you so much for joining us. Tonight's topic, we have another citizen science project called Active Asteroids. We'll be back in 6.8 seconds. The Active Asteroids project is designed to help answer two important and outstanding questions in astronomy. Number one, where did the water on the Earth come from? And number two, where else can we find water in the solar system right now? And answering these questions will have important implications for science and engineering. Jeff has taken point on this project and we'll delve into that right now.
Okay, if you could share my screen. Thank you. Okay, it is, of course, another Zooniverse project. I think we might run out of those soon unless we get lots more guests or they start filling up more, but hey.
We have more.
We have more, yeah.
From other sites, different ones.
Yeah. And so standard Zooniverse stuff, active asteroids, which, you know, are different from those lazy layabouts that just float there.
Okay.
But, you know, the about, classify, talk, collect, you guys all recognize this from the other ones. And we're basically going to be examining images to see if a asteroid has a tail or a coma, which is just dust or gas cloud around it.
And there's the link for this particular project on Zooniverse.
Oh, okay. Yeah, cool. And speaking of links, what's up?
David says, I'm present, teacher.
Hi, David.
David's our teacher, actually.
Yeah.
Thanks, David, for being here. Really appreciate that.
I think he's treating us as he wants to be treated.
Oh, okay.
The old golden rule. This page does have a link to an article about is an asteroid a comet, which is kind of the active asteroid thing. You know, tail with a and or a coma around it.
Yeah, that's a really good question. It's like, why is it? What's the distinction? What makes them different? Right.
Yeah, and it's a fairly recent article. If you notice the date on it, it's only a few days ago.
Oh yeah.
As of this filming. This is all of the article. The site has the link to it, and you can go read it on the site. I just wanted to point out that it's there.
And there's where you can start again, right there.
Yep.
Zooniverse.org/projects/
Yep.
The rest of that.
And like most other Zooniverse projects, you go down a page. One, you get a sample of the types of images that you'll be seeing. And if you notice, they have little aiming points here to see which objects you're supposed to be looking at. So that's the kind of images that you'll be looking at. And as of yesterday, 37% complete.
Awesome. And Christina has joined us. Thanks so much for being here, Christina.
Hey, Christina.
Really appreciate that.
So I don't know if they're going to be adding more or not, but there's a lot of images on there already. So there's plenty of work to do. And this one isn't as involved as some of them.
Mm-hmm.
So it should be, you know, if you just want to spend some time zoning out, clicking on stuff, this is pretty much the one for it. And I'll show that later. And, you know, this is the about, and Pam mentioned some of this here about, you know, where did water come from on the Earth? I mean, we've pretty much answered it, but there's a couple of different theories. And so I guess they're fighting, and this is one of the ways that one of them wants to see if they're winning, if they win.
Okay.
And where to find it in space. Well, pretty much no. Anytime, you know, you just go look at an asteroid and see. But I guess this helps them some. and it justifies some funding. But but here's the thing: there are they found fewer than 30 active asteroids since 1949.
That is a tremendously low number.
Yeah, which, okay, they're interesting to find simply because they're an oddity, not,
Okay.
you know.
But it's weird to me to devote a whole project to it with that few. But I guess if they're looking for more, this is a good way to do it, to get the crowd to basically answer the question. You know, go through all the images and determine whether they're there or not.
And it's very low overhead too, because they're using already generated images from a different project.
Oh, okay.
And just chopping them up and having us look at them. So it's kind of like their time was spent putting this together and putting it on Zooniverse.
Oh, right. You said one image yields, how many was it?
I forgot the 50 that I told you was wrong.
Oh, okay.
But it's still a lot. And we'll have a picture that shows us.
Oh, okay.
In fact, right here, this is the about section that's on Zooniverse. And why search for active asteroids? Pam already covered this in her introduction. They go into a little bit more detail. And then the one that I'm interested in, appraise volatile availability for prospective asteroid mining efforts and sample return missions. And inform spaceflight engineers seeking more practical, inexpensive, environmentally responsible sources of fuel, air, and water. Why not just say economically responsible?
Yeah, in situ, basically.
Yeah, so that you don't burn 99% of it getting it up there.
Yeah.
But hey, but this is the image that they're getting off of the dark energy camera.
Well, if that's not 50, it's darn close.
What's that? Oh.
Isn't that parsed into the separate images?
Yeah.
Okay.
But the 50 comes from the instrument has about 50 times as many pixels as the average smartphone.
Oh, interesting. Okay.
And smartphones have a lot of pixels, so
okay.
So it's a big image, and yeah, could be close to 50 in there, but if someone wants to count them, I don't. But so what they do is they separate it into sections. They use a computer to determine where it is by looking for astronomical objects that are known.
Okay.
That way they can position it in the sky. They look for asteroids in it, and extract the pieces of this chip that have asteroids and enhance it, basically turning up the, playing with contrast and brightness to get everything they can out of it. Because they wanted this camera because it takes images of very faint stuff.
Oh.
And the tails on these are very faint.
Yep. Right.
So that's
that's great.
Yeah.
And it's a good way to reuse the materials they've already gotten, like you said. It's
and this camera, even though it wasn't designed for looking for asteroids, can see about 10 times fainter objects than the next best asteroid survey.
Wow.
So, they're not looking for the asteroids themselves. They're looking for the dust around them. So that's why they're using something like this. Lets it detect faint tails. And so, then they go into the challenges. One out of 10,000 asteroids they suspect are active.
Okay.
So.
Well, that's certainly not true of the 30 they found.
Well, that's just because they found 30.
Yeah.
The thing is that previous instruments weren't sensitive enough to see most of these.
Okay.
So that's why they're guesstimating 1 out of 10,000, but they don't know yet.
Oh. And David weighs in, and he's saying it's part of a well-known citizen program you guys have touched on before. Astronomers are asking volunteer citizen scientists to search the sky for what they call active asteroids.
Yep.
Excellent. Thank you, David.
I didn't see that on the screen when you went to show it. But okay, and this is a picture of asteroid wrongs. Sorry, we were watching the Meteorite Men. Meteor right, meteor wrong.
Meteor wrong, yeah.
Yeah. But
I do like it though, Jeff.
Yeah.
Good.
A is the only actual meteor in here with a tail. Everything else,
Do you mean asteroid?
asteroid. Yes,
Okay.
Sorry. We just talked about meteors.
Yes, got it.
Asteroid.
Right, yep.
Oh, and it's only tailed because of a long exposure time. So that's not actually a tail. That's just it moving through the screen.
Okay. Yeah, like if you leave the aperture open on a camera,
Yep.
you'll see at night, you'll see star trails. And that's
Mhm.
not a tail of the star. It is the star at different points in its
Yeah.
I don't know what that is. Maybe David knows.
Yeah. B is just a lens flare off of something bright.
hmm
Like maybe they're making another Star Trek movie. The latest ones, the director really loved lens flares. Apparently, bad camera work is in. C is a galaxy, so not a tail. D, this little squiggly is cosmic ray,
Oh, right. Yeah.
as is that. And, any of the really thin squigglies are cosmic rays.
Okay.
Oh.
Here we go. Oh, is the tail a result of outgassing?
Most cases, yes.
Excellent. Okay.
And that's why they're looking for these, because it shows that they likely have water on them, or
Oh, that makes sense, which is what we're looking for. Yeah.
Right. Yeah. Although
okay, cool.
in one of them, and we'll see it later, it's not actually water. And that one was interesting to me.
From water. Yeah. David from water.
Yeah.
/ ice. Yeah.
Yeah. E is just a cluster of fuzzy background objects, probably galaxies.
Oh, okay.
But they might, if they're close enough together and fuzzy enough, might look like the coma around an asteroid. So, so those are the things to watch out for. That's what this image is showing you.
I do like that part about Zooniverse. They do mention things that are, you might see this, you might see that, and it's not quite exactly what what we're looking for.
And then we get into the tutorial. Welcome. They do say, this is the first time where they say they're looking for active asteroids that display a tail or a coma, and then they define coma as a cloud of dust and gas.
Okay.
Not someone who's unconscious.
Got it. Maybe. The water could contain microorganisms dormant and still alive. What do you think, Jeff? That's
Possible.
That's one of the theories, right?
It's possible, I suppose, maybe. But
we gotta go there. We gotta take our
Yeah.
our kits and take samples and run them through the labs and.
Yeah. The main thing is that organisms take a while to develop. So how did they develop to be on those asteroids? So that's now they might contain protein fragments and stuff like that are developed through chemical processes
Right.
that could seed someplace with life, or if they came from another solar system, maybe. But we'll figure the majority of stuff here built up in this solar system. But we do get occasional visitors from other solar systems,
Right.
Zipping through. So some of them might have been captured. I just wouldn't bet on it myself. That's just my own opinion.
Wasn't there a really neat picture with this image, this part of this first, segment of the? I thought that was a really cool image.
It was an asteroid. It was
Okay.
It was a potato-looking rock.
I see. Okay.
But this is one of the first things. Is there an object in the center or not?
Right.
Now, I will say that in all of the ones that I did, and I only took screenshots of some of them, there was never not in that image.
There was always an object.
There was always an object.
Got it.
But this is saying that it might happen. Although this might just be from an earlier run before they sorted some of those out. I don't know. Or I just got lucky. But also, none of the tutorials show the targeting lines that you saw in that first one. So,
yeah.
But all of the ones that I saw have the targeting lines. So I suspect that they've revamped stuff in here.
Got it.
But I don't know. Like I said, I only saw a small subset of them. So who knows? Who knows what we'll find?
Okay, cool.
But, this is an example of something with a tail. Oh, hey, Splash.
Welcome back, Splash Autumn. If we have identified there is a bigger asteroid that can hit us and cause devastation, what are the effective ways that we can create to destroy it? Maybe a big laser gun in space. What else can we do? That is an excellent question, and we've been watching some stuff about that. In fact, we saw something right before this. Do you remember who that was? It was
I don't remember.
Petrov.
Yeah.
Shoot, what is it? Darn it! I'm so sorry.
We'll put a link in here after.
Yeah, we'll try and find that and add it to the comments afterwards.
But the main thing is using a nuke actually viable?
Right.
And to destroy an asteroid, no. For one thing, if we destroy it, it's still a whole bunch of rocks heading toward us.
Too many parts that can fall on the earth and make things worse.
It's like
actually
getting hit by a pistol or getting hit by a shotgun.
Yeah.
Which is worse.
Yeah, good point.
But they are talking about using it possibly to push it.
Yeah, David concurs. No, we move it bit by bit, not blow it up.
Yeah.
Also, David said this, at least these rarish asteroids could end up being a future refueling station. Yes.
Yeah.
Absolutely.
And they did mention that in their about, and that's
in the Zooniverse.
Yeah.
About. Okay, got
justifying why they're doing this.
Cool.
And because that's what I'm interested in. But they what is
okay, and let's say, but can we hit it in long range if it is possible, since we can predict it early? Ooh.
None of our I've had a discussion about this on another forum somewhere. None of our ballistic missiles can make it much out of our atmosphere.
Oh, really?
Yeah.
Okay.
So we would have to unmount the warhead and mount it to something else. A Saturn V type rocket, or maybe even Musk's big rocket might be able to do it. If the warhead's small enough, it might have enough thrust to get it out somewhere.
Wow.
But here's the trouble with that. You're trying to hit a bullet with another bullet.
Yes.
So
good point. I say we go mine it.
Yeah. Well, move it and then mine it. Yes.
And David says maybe the ice can go in his bourbon.
Yeah. You might want to filter it a little bit.
Maybe.
You never know what other chemicals are in there.
I've seen that episode of Doctor Who.
Yeah. But yeah. But so this tail here. Now they indicate it with blinking arrows. Taking a screenshot of something that's blinking. Eventually, you get one with the blink on. Just saying.
I'm familiar with that phenomenon.
So this is what a tail generally looks like, and it's fairly faint, but is visible. And they've got it cranked way up on here. And here's a coma, kind of coma and a tail, because it's kind of coming off this way. It's not just a ball of gas around it.
It's not as well defined, though. I think that's the point there. Right?
And it extends all around it, not just in one direction.
Oh, I see. Yeah.
It's kind of like it's boiling off in all directions.
Okay.
And they refer to it as a fuzzy shell or smudge. And there can be multiple shells, although I haven't seen that. That'd be interesting.
Yeah.
And these are lookalikes. And we've seen some of these before. This is just all tails. Everything has a tail. It means the telescope is moving.
Oh.
So someone bumped it. Fuzzy. Everything is fuzzy. Well, that's again probably clouds or overcast. Scattered light. Bunch of objects stacked up on each other.
3 and 6 are clearly artifacts of the instrumentation.
Yeah. 4 is a bunch of stuff on each other. That long, thin line, and basically it looks like someone just took a ballpoint pen and scraped it across the image. Those are cosmic rays. And down here, telescope mirror. Apparently in the very center of where they're taking all of pieces from, you're going to get an image of the mirror in there.
Oh, and David chimes in with, from your diagrams, they are very comet-like, especially that curved coma cloud. Could easily be mistaken by amateurs as a comet. I don't know if any amateurs would see these, David. Remember, this is from a large image taken by a very, very sensitive piece of equipment, and then they break it up into a bunch of little ones and blow those up. So I'm going to go with probably not visible to amateurs even to begin with.
Yeah, I don't.
Is that what you think, Jeff?
I think so. It's possible.
What I'm getting out of this.
It's possible. But I suspect that anything close enough to be visible to us would be moving fast enough that they'd call it a comet anyway.
Oh, interesting.
Because it'd be coming, it'd be looping around the sun.
So maybe that's part of what distinguishes these from comets.
Yeah, because these are pretty sedate in the, most of these are pretty sedate in the asteroid field.
That's very interesting that they have tails or comas. And I was wondering, do they include both types in this count of 30?
Yes.
Oh, wow. So
basically it's anything coming off.
Wow. Okay.
Yeah. Which,
active.
Yeah. So this is really faint. I suspect that, we just don't have the stuff.
Oh, yeah. Let's talk about that again, David. I think Jeff may have mentioned it.
Yeah. I don't remember exactly, but it's the Dark Energy Telescope or Dark Energy Project.
Yeah, something like that.
But they're very, very sensitive telescopes, and they're not meant for this project. It's just that these guys are repurposing those images.
Right.
But it's some of the ones that gathered the most light and can take the faintest images. And so they're just repurposed it to look for these asteroids, which is, I think, pretty darn nifty.
I think it's awesome.
Yeah.
Hope that helps, David.
Yeah, and
thank you for asking.
And they do mention it in the about on this.
Got it.
On this, okay. So if you want to look for it.
Most of these have quite a bit of information. Sometimes sources. They talk about the team and they give contact information. So if you really wanted to dive into it, there's probably a lot of possibilities actually in the project on Zooniverse for that.
Although I will say on this project, that kind of stuff is pretty light.
Okay. The one I talked about last week, that was like super intense, but it's been there for a long time. It's been a project for a long time. So they had a lot of information on Zooniverse. Very good. This is a great groundbreaking subject. And and you know what? It's pretty cool. You'll see in a second. Jeff will have a couple of samples, and it's quite doable. Some of these kind of seem like you need to be trained for it, but this one's really good for that. Yeah.
Now, feeling uncertain, look at the field guide. I'm gonna say that's not going to do you a lot of good.
Okay.
I'll show you the field guide. It's not nearly as good as some of the other projects, but it's not as necessary for this one. But I'll just say that they kind of phoned that one in.
Okay.
The field guide. And part of it is that they only have 30 samples of what's right.
Oh, right.
Well,
and that's how these work. They get better and better as they get more and more help and more, they crunch the numbers more, and they they have outcomes after a while. They have, results.
Yeah. So, and one of the things that they do, because there's so few actual active asteroids out there, is that they'll include confirmed active asteroids just so that, so that you can see whether you're actually picking right or not. And two, I suspect it's just so that you don't zone out clicking a bunch of no's.
Okie dokie, to keep you on your toes. Got it.
Yeah. But they do give feedback on them, so that's actually good.
Nice.
And
we got a question. Yes, absolutely. Gregory, thanks so much for joining us. You can absolutely ask questions. That is what this is all about. That is why we are here, and we want to help you out.
Yeah.
Ask away.
Yeah. This is, again, they're pointing out here, is there an object in the center of the image, which kind of a repeat of one of the first slides in their tutorial. And they spend too much time on this because I don't think that they do that anymore. So,
okay.
And here's the field guide. Now they have a whole bunch of different categories and, you know, a few of, and they'll indicate what's an object of interest. And although coma is an object of interest, but it's, they don't mention that. Trails, blurry images, you know, dead columns, all of the artifacts that you're, you know, that you expect to find. But these images that you see here are pretty much the only examples that you have of each, because here's the asteroids, and they just have the same image that you saw in the thing, and they talk a little bit about what an asteroid is. Yep, okay.
Well, but if you know nothing about it, it's a great way to start learning things.
But it doesn't help you spot them. That's my complaint about it. And then here's tails. Again, it's the same image that they show in the, you know, in the selection for the.
And they could have made it a little bigger. I bet they have some feedback though, and you can, you know, if you're in the project. Well, I know there's forums too, right?
Right, and they talk about it, but they don't say anything. They don't say much more than they've said before in the tutorial. So we're going into an actual image to pick. And do you see comet-like activity such as a tail or dust cloud coming from this object? And if you notice, it looks pretty fuzzy. And nothing, and the other things in here aren't fuzzy, so it's not a blurry image. So I said yes. Oh, and this also indicates this button down here reverses it between dark on light and light on dark. So sometimes you can see it better in one way or the other. So I took to checking most of them that way just to see if I get a different answer. But in this case, it does look like there's a cloud around it, so I marked yes. And here we go.
Oh, and they said you?
Yeah, congratulations, you successfully identified activity in a thumbnail known to contain an active object. Oh, okay. What does Gregory?
So, Gregory, thanks so much for mentioning that.
I don't know anything about space or asteroids, but last week, a rock the size of a melon fell out of nowhere from the sky into my backyard. It looks like nothing I've seen before. Well,
depending on where you are, you could get the local college involved. I know when we watched Meteor Men, they actually go to the guy that's in their area. I think it's Jeff. He lives in Arizona, and he goes to the guy at ASU, which is Arizona State University, right? And he asks him. So now you might want to get a couple of pieces of information, like take some pictures of it. Where is it? What does it look like? And figure out the GPS.
Yeah, location.
Yeah, because that's one of the things that they do with these finds. They actually chart them out in, you know, on the ground. They try and figure out where they are on the Earth, and they'll talk about, you know, where asteroids kind of fall, and that they call it a strewn field. There's lots and lots of parts of that, so you may actually be able to make a real contribution to science.
Oh.
Okay, he says some more here. It's extremely dark in color, darkest it can be. Oh, and I see color that you must be in somewhere like England. It has little spots like seeds. Now, oh, and that's a really good sign too. That's olivine, I think. Now, can you put a magnet on it, and does the magnet stick to it?
Yeah.
And that's a really good indicator too, because most meteors have more iron in them than Earth rocks do. That is very exciting, Gregory. I hope you have a real find there.
Yeah, because actual meteors are pretty pricey pound for pound when they're sold. So if it can be confirmed as an actual meteor,
depending on what kind it is too. I think there's various types and various prices.
Even the common ones are decent.
Yeah, if you think about it, they're more rare than anything we can find on Earth.
Yeah.
So, including diamonds, I mean, yeah.
Those are dime a dozen. Okay.
Yeah, pretty much.
Okay, so here's another image. No real dust around it or anything, so I just marked no. Here's one that looks like a tail to me. Oh, what does
So
David say?
thanks, David, for weighing in. Gregory, is this something you saw? David says, I get lots of people bringing along rocks, but it needs to be seen to fall or checked at a uni. He means university. By the way, the magnet test is not accurate. Oh, well, the Meteor men always have a magnet with them, and
Right.
that's how they...
Unless they're looking for a stone, but it's not going to tell you, yes, this is definitely a meteor, but if it sticks to it, it's more
If
more
it doesn't
likely.
stick to it...
It might be a stone meteor, but...
Yeah, if it's a stony one, there's not as much iron. It's very weak.
But as dark as it is, it might be might have some iron in it.
Yeah,
but,
get an expert in on this,
Yeah.
wherever you are, Mr. Buttocks. From England, yes. Check the same thing. Does attract you very strongly. Ooh, well, you know, like the Magic 8-Ball says, your chances are good.
Yeah, so yeah, I would definitely take it to university because
Absolutely.
they'll be able to look at it and see the crystalline structure of the iron in there.
Yeah, they slice them, they polish them up. And they etch them sometimes. There's lots and lots of different things that they can do. And if it's not at one university because it's, you know, they don't have that kind of a department, check somewhere else.
Yeah.
Somewhere around you most likely will have somebody on hand who can give you more information, like directly. It can tell you and look at it and so forth.
Right. Yeah. So this one looks like a tail to me. I flipped the image and still looks like a tail.
Very much a tail.
Yeah. And so I said yes, and yeah, it's another one that's been seeded. Now here is the thing here. Every one of these that I found that actually has a tail or coma has been seeded. I guess they're still so rare that they throw a few of these in there just to keep people interested.
Makes sense. It'd be pretty boring to see.
Just basically go, yeah, exactly. Exactly. And here's another one. Looks like a tail to me.
Well, and heck, once they do have, you know, more, you're going to be, like, for example, this one. You told me the story about this one.
Yeah, this one, I actually didn't think it was because that doesn't look like the kind of tail that I'm used to seeing in the images. So I said no. But apparently I was wrong. So I guess they're calling that a tail. Just didn't look like one to me. But so just as you know, that's what a tail looks like also.
Cool.
And then here's a dust cloud. I said yes. And so they're all like that. This isn't one of those that needs like a science degree to work. You just basically click yes, no. And that's...
Here it is, David. Thanks so much, Gregory, for responding. He actually saw it fall from the sky. He had his back towards it, though. I got saved. I was only like 5 meters away. It could have hit me. What? Wait.
Yeah, actually, if it had hit you, you would have been in a very, very rare club.
Very rare.
Yeah. But okay, and this is the team that's putting it together. Colin, Chandler. Splash Autumn. Just curious, is it possible to create a bunker that can protect people in case of the effects of an asteroid impact? It all depends on how big and where it is.
Yeah.
And basically, the one that killed the dinosaurs off, if you were anywhere near the Yucatan Peninsula at that time, yeah, you'd be toast no matter where you were. Even if your bunker survived, you'd be in the air in your bunker coming back down, you know. Yeah. So you'd probably be dead in the bunker if the bunker survived. So David.
Thanks, David. Removing a small corner of a suspected stone meteorite with a file or bench grinder and examining the exposed face with a loop. If the interior displays metal flakes and small, round, colorful inclusions, it may well be a stone meteorite.
Yeah, and that's why I would take it to to someone at a university because they'll have the better. Oh, does he say? Oh, yeah.
You may be right, David.
Yep. But who knows? If we treat it as a possible, then someone else might. We're giving good information whether it's true or not.
Absolutely.
Colin Orion Chandler got this. Okay, yeah. Thanks, Gregory. And co-founder, just showing how good they are at their web work, as they're not able to scale their images. Other contributors, the Science Advisory Board, all of this is on their website.
Hey, we're all learning.
Yep, and this is their team with links. So, if you need
is
to
that that's under the team part of the okay. Yep. So you can find out more about that.
Yeah,
under,
it's
there
under
it is,
team.
The team
Yeah.
Sort of tab.
Yep.
Thing there. So
yeah, and proof of concept. They actually had a proof of concept where they used this process to find a known one. So they basically put an image that had a known one in it and used looked in these images to see if they could spot it. And yep. And then here's one that while preparing for the project, a newly found asteroid known as 6478 Gault, and made two key discoveries. First, the team found that it had a comet-like tail, so they found what they're looking for here. So they found a new one. The white arrows since at least 2013. So that's a long time for it to have a tail.
Wow.
And because the tail is thought to be, and second, because the tail is thought to be caused by Gault spinning so fast it's breaking apart. So in this case, it's not water ice that's vaporizing. It's just a tail of debris from it spinning so fast, which I find absolutely fascinating.
Yeah. Wow.
I mean, so this is something that they didn't expect to find.
Okay.
So.
Hey, you never know.
Yeah. So, who knows? In looking for this stuff, you might find something that no one's seen before, like this.
And I know on other projects they've actually done some things like they've named the people that found that. They've I don't know, I forget exactly what, but there are some possibilities for.
Well, this has a number and a name. I don't know if Gault was one of the people who found it or not. I just don't know.
Let's see. What is kind of average size of these active asteroids?
I have no idea. They don't say.
Oh, good question, though.
Yeah.
I can imagine they're pretty small with this whole, concept of they're using a very, very sensitive camera, and they're breaking apart a larger image.
Well, remember, they're not trying to find the asteroid. They're just trying to find the tail.
Yeah.
That's why they need the sensitive camera. So I have no idea. They could be big. They could be small.
And maybe that'd be a great question to ask. That's at some point they would be, going into the outcomes and more information. The field guide might get updated. And
there are places to ask questions in any Zooniverse. You can post questions in the forum. Yeah,
forum, right? Yeah.
Yeah.
Very cool.
And
that'd be a great place to hang out with other scientific type people.
Yeah. Yeah, they simulated the classification process, by basically having a bunch of them look at the images and try to do what we're doing. An unusual smudge that kept showing up around one particular object. This was a centaur, an icy body with an orbit between Jupiter and Neptune. And the follow-up observations. Again, they're simulating the way we would look at stuff. Discovered the object was active. So they actually found an active asteroid all the way out between Jupiter and Neptune. So they don't have to be near the sun to be doing this.
So David says that if they come from the asteroid
belt,
Oh, belt, got it. They very well could be the seeds of life that kickstarted Earth's evolution, especially the water content issue.
Well, yeah. In fact, one of the theories is that Earth got pelted by a bunch of icy comets or asteroids, and that's why we have so much water.
Right.
So could be.
Good stuff.
Yep. And that's it for this.
Oh, okay, let's get back to us. And yeah, thanks so much for all your questions. Yep, exactly. David, that is the right word for it.
Yeah, and who knows, some of these might be captures from other solar systems. I mean, and that could have, you know, and that could spread stuff too, but that's unlikely. But, you know, hey, mosses and molds spread by spores.
And tardigrades can last till they get more water, apparently.
Yeah, don't know how well they survive re-entry and impact.
It's like a lot of things, you know. Something survives
that
almost
sounds
every
like an experiment
time.
to me. I wonder what PETA would say about it.
Oh, okay. Thanks, David, very much. We still have a little bit to go. I want to tell you about the stellar events happening this week, and this is about the same time we do that every week. And if you have more questions, absolutely let us know. If we can't answer you in the show, we will come over and answer them on the platforms. All right, so we are talking about October 15th through October 22nd. On the 17th, Neptune and the moon are in conjunction. On the 20th, there is a full Hunter's moon, and the weekly space hangout has a guest. Meg Russell will be talking about volcanism and ice on Mars from the Planetary Science Institute. Yes?
Well, you have it written out as PSI for planet, and I'm just thinking she was pressured into doing it.
Maybe.
PSI?
Yeah, I get it. On October 21st, Uranus and the moon are in conjunction. Also, from the 21st into the 22nd is the Orionids meteor shower peak. However, the moon will be about 1 to 2 days after full. It'll be big, it'll be bright, and it'll be in the sky for most of the night. These are normally visible after midnight. And then on October the 22nd, we're back to Friday night and our Friday night show. You can find us on Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel.
We should hit 100 live shows soon. Pam's estimating November 5th of this year, 2021, we'll have our 100th live. Not necessarily of this show, but Pam's been doing lives for a while, even before the show started, because we just had our 1 year anniversary of this show.
Right, which once a week, that's only like 52. So
yeah. So if you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, October 22nd, and help us welcome our next guest, Janet Ivey of Janet's Planet.
Have you heard of Janet's Planet? Can't wait. She is a delightful person, and it should be really interesting and fun to hear her talk about how she's gotten involved with this and what's inspired her and those kinds of things.
And she's done so much that I suspect that we'll have her on more than once.
I think we will, yes. We are looking forward to some future guests. I think we're going to have Dr. Adam Dipert back on November 19th. He is the space juggler. He will be talking about his helium-3 experiment this time, however. And
that was just, to me, almost more interesting than... No.
Oh, yeah, both are fascinating.
Yeah,
totally
both are
fascinating.
But if you're a science geek, that's going to be really nifty.
Yeah, come on back. And we are talking with some other folks. We haven't really nailed down a date for them quite yet. Pamela Gay said yes. David Dickinson, we would like him to come back. We are looking to talk to Daniel Fox, Greg Allison, Tim Pickens, Sherry J, Chelsea Good, and Don Dowdy. Have an awesome week, people, and we'll be here again next Friday at 9 p.m. Pacific time. Bye-bye.
Bye.